So let's think about bad first moves, moves that are just like disastrous. So what if I move the coyote across first, all by itself? I take me and the coyote and I go across. Why is that a bad decision?
Because he can eat the
Because
sheep.
the sheep eat
Yeah.
corn.
You
Yep.
take the sheep.
Yeah. So if I just move a coyote across, I've left behind the sheep and the corn. The sheep's going to chomp down the corn. We're in trouble. So I shouldn't do that. That's no good. All right, let's move the coyote back. That was a bad idea. Move the
What
coyote back.
about
All right.
the sheep? The sheep first.
Good. So moving the sheep first seems wise because that leaves the coyote and the corn alone, but the coyote doesn't want the corn. So I move the sheep across. And then what do I do?
And then return back. Empty
Yep, come on
boat.
back. Yeah.
And the corn first.
Take the
then
corn across. All right.
no, because
Oh.
it's corn with sheep. The sheep will eat the corn. It should be the
But not
coyote.
if I'm there. Not if I'm there with it, right? So if I'm in the boat and I come over with the corn, I can fend off the sheep with my fists or something. I don't know. Say stay away, or I can keep the corn in my pocket briefly. Okay, so if I go across with the corn, and let's see, I'm going to try to move the boat. Let's see if I can. I might accidentally move the river when I do that. Yeah, I'm going to move the river if I do that. Yeah, let's see. Well, so I can't move the boat by, oh, maybe I can. Here's an idea. What if I do it like that? Well, that's most of the boat.
Your boat is broken.
We're gonna leave part of the boat behind. You don't need a whole boat. We can just use part of a boat.
You don't want to
That's fine.
sink in the river.
Okay, so I moved the corn and I'm over there with the boat and the sheep. That's okay, right? I can be there with the corn and the sheep. I can fend off the sheep. But if I go back across by myself, I'm in trouble. All right, so what should I do?
Take back the sheep with you and leave the corn on the other side.
Aha! I take the sheep back with me with my boat like this. Okay. Now what do I do?
And then transport the coyote
Yeah.
and leave the sheep.
Sheep. Nobody likes sheep. Well, that was a bad decision. I shouldn't have grabbed them both at once. Here, I'll take the boat. Let's imagine I did this at the same time. There. Use your imagination. All right, that's good for you. Cool. Coyote's not going to eat the corn because that doesn't like that. And then I guess I can come back and grab the sheep, right?
Yep.
All right, we did it. Okay, now success. Everything got across. Okay, so I don't know why there's another copy of it, but there it is. That's fun. So here's some questions to ask yourself about this problem. What information matters? So these are like good general kind of problem solving questions that I'm sure you get many of your students pay attention to. What's the information that matters in this? For this kind of problem, here's questions that are useful to have and to ask. How can the stuff that matters, whatever that ends up being, how can the stuff that matters be arranged? And so if you have some way of thinking like, okay, here's the things that matter, and here's how all that stuff can be arranged, that helps you start to get the problem organized. But then all these different arrangements of the stuff that matters, they're hooked up in various ways. And so once you start to like get like half a hint about how to answer those things, what you might notice is there's a lot to keep track of. And so then the sort of final question you might ask is, how could I keep track of everything that needs to be kept track of? Now, anyone want to not answer these questions? Good. We will come back to these questions. Do you want to volunteer a story about how you figured out the answer to this problem? How did you figure out how to get the critters across?
Boat capacity. We have to consider the from that information, the boat capacity. So it takes
that's
one
really important,
passenger at
right?
a time.
Yeah, that's right. But did you do anything systematic to actually find the answer here, or did you just mess around with stuff until you got it?
Yeah, like try and error.
Yeah.
Then back to that instructions or information again.
Yeah, great. And this is probably, for this problem, the most efficient way to solve it, is to just use trial and error. but it wouldn't be hard to change it so that that's not going to be an effective strategy, right? So you can make the question slightly harder. So what if we had more critters, right? What if we had, instead of just 3 critters on one side, what if we had 5 critters in complicated relations? This one will eat that one unless the other one's around. You have this really complex connection of critters. And now suddenly trial and error is going to get hard to do because there's a lot of stuff around. And so while trial and error is really effective with this particular problem, and is probably the most efficient way to solve it, as soon as it gets a little more complicated, trial and error starts to lose its shine. It starts to look a little scary. And so one of the things you might have in mind is this. A lot of times what simple problems are useful for is as places to test out ways of answering questions like these. So you find the answer and then work backwards from the answer to answers to these questions. And then when the problem gets more complex, you can use how you answered these questions to answer the more complex thing. So I'll give you examples of that as we go along, but that's what I want you to have in mind. A lot of times what's helpful is to go from the answer you have, work backwards to a method for finding that answer. And then when the problem's more complex, you have a method to apply. Okay. So I'll show you one way to answer these questions. It is not the only way. It's just one particularly helpful way. So the first question was, what information matters? And here's one way of answering that question. You need to know these things. You need to know where the sheep is. You need to know where the coyote is. You need to know where the corn is. And you need to know where the boat is. As long as you have all that information, you kind of know what's going on. If you don't have one of those pieces of information, you don't know what's going on. And then the second question was, how many different ways can that be arranged? And I said 16 different ways here. Anyone have an idea? How did I come up with 16 different ways that stuff could be arranged?
Four times 4?
It is 4 times 4, but even better. So where can the sheep be? Which side? Yeah, go ahead.
2 sides of the river.
Yeah, the sheep can either be on the left side of the river or the right side of the river. Where can the coyote be?
2 sides.
Yeah, so we have 2 sides for each one of these.
Mm-hmm.
So it is 4 times 4 times 4, but even better, it's 2 times 2 times 2 times 2.
Yeah.
All right, so we have 2 places the sheep can be, 2 places the coyote can be, 2 places the corn can be, and 2 places the boat can be. And so that gives us 16 different places things can be. And here's a nice way to write all 16 of those down. Oh my goodness, I'm doing a terrible job keeping track of the chat. There's 13 messages and I haven't read any of them. Ooh, 2 to the 4th. That's the correct answer. I'm loving everything about this. Sheep eats corn. Yes, sheep does eat corn. All right. Whoa, there's an actual detailed solution here. You guys are amazing. Okay. Well, and then there's all the criticism. Let's ignore that part. So here's a way to present all 16 of those ways. Here we are. I'll tell you how I made this chart in a moment. First, this is kind of annoying. I'm going to move it over here. I don't like where that is. Oh, I'm moving one of the lines now too. I shouldn't have done that. One more try. I'm leaving the 1 behind. I can fix that problem. There. All right, much better. So the way I did this here, you want to think there are 16 different arrangements. In half of those arrangements, the boat's going to be on the left, and in another half of those arrangements, the boat's going to be on the right. So what I did here was I took boat. Where's my highlighter thing? There we go. Boat. I took half of them. I made it left, and I took half of them, and I made it on the right. Now, in half of the arrangements where the boat is on the left, the coyote's going to be on the left, And in half of the arrangements where the boat is on the left, the coyote's going to be on the right. And the same for the arrangements where the boat's on the right. In half of those, the coyote's going to be on the left. And in half of those, the coyote's going to be on the right. And then you carry on in this way. So you think about those ways that you have the coyote and the boat being on the left. In half of those arrangements, you're going to have the corn on the left. And in the other half of those arrangements, you're going to have the corn on the right, and so on. And so a way to generate all 16 options, let me erase this for now. A way to generate all 16 options is the following. You first put down 8 L's for the boat being on the left, and then 8 R's for the boat being on the right. And now you alternate by 4s, so 4 L's, 4 R's, 4 L's, 4 R's. And then you alternate by 2s, so 2 L's, 2 R's, 2 L's, 2 R's, blah, 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 blah. And then you alternate just every other one, LR, LR, LR. And now each row here represents a way the stuff we care about can be arranged. But some of them are bad, because in some of these, something's getting eaten. So as an example, let's see if we can find one where something's getting eaten. Yeah, good. So the fourth one down, this one, 1, 2, 3, 4. Oh, that's not what I meant to do. I meant to make that a little more permanent. 1, 2, 3, 4. There we go. This one. So there, I am with the boat on the left side of the river, and the sheep and the corn are all by their lonesome on the right side of the river, and so that sheep's going to eat the corn. And so you can go through here and you can cancel out the ones that are bad. So that one's no good. Let's see. I think this down here with a whole bunch of R's, right? So I left, this is just a complete failure of your responsibilities, right? Like you left everything on one side of the river and you went to the other, just like no attempt to help anything. So that one's no good at all. And this is similarly just like a complete failure of your responsibilities, right? You left everything alone on the right side of the river and you just took off for the left. That's no good at all. And you can go through and find all the ones that are bad. So that one's bad. I think 6 of them total are bad. Those 3 are bad. Let's see who else is bad. Oh yeah, this one's no good, right? This is also a complete abdication of your responsibilities. You just left everything alone on one side of the river and you went to the other. Oh, this one's not like that. This one's bad for a different reason down here, right? I got confused about which one was the boat and which one was everything else. That one's actually fine. These 2 are bad. And then 1, 2, 3, 4. I think this one's bad. On that one, I'm over on the right with the coyote, and I left the sheep and the corn by themselves. And there are 2 others that are bad. Which ones? Oh, I should keep track of the chat. Someone might have put the answer there. No, not yet. All right, where else is, there's 2 other bad rows, 2 other rows that represent things getting eaten. If you find one of them, I'll show you a trick to find the other. Let's see about 12. 12, I think, is bad. Let's see here. So 1, 2, 3. Oops, let's see. I'll use my pointer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see here. So in this one, oh, I think that one's okay because I'm over there in the boat with the sheep and the corn. Everything there is fine. But look at the one above it. There, it's me over on the right with the corn. I'm over there eating the corn by myself, and I just completely ignored that the coyote's going to chomp down on the sheep over on the left-hand side. All right, so this one's bad. And now if you look at this, actually, there's a fun thing to note. So let's see here. This is the other one we found out was bad just now. There's some fun symmetry. When you flip over that line, all you do is flip L's and R's. And anything that was bad, but on the top of that, once you flip it over the line, you're going to get something that's bad on the bottom of it. Because what makes it bad is when two things that eat each other are left alone on the same side. And if all you do is flip L's and R's, you're still leaving something alone and it's going to get eaten. And so you see that this and this are the same except you swapped L's and R's. This and this are the same except you swapped L's and R's. And so this one, and I bet it's that one, is also bad. And let's see here. Yeah, so on that one, let's see. I'm hanging out over on the left with the corn, and yep, the sheep and the coyote are left by themselves. So the coyote's going to eat the sheep. All right, so once you recognize the symmetry, actually you only have to find a few of the bad rows, and all the other bad rows just come out of hiding. So there's a total of 6 bad rows, leaving us 10 good rows. And I just wrote them out here. These are the 10 arrangements that are okay, where nothing's eaten anything. I'm going to pause there for a moment. Is everyone on board? Does anyone have questions about what we've done so far? Okay. So we have these 10 permissible arrangements. So let's go back to the questions we asked. What information matters? The way I've decided to answer that for the moment is the information that matters is where the sheep, the corn, the coyote, and the boat are. How can the stuff that matters be arranged? 16 ways. And then I'm just going to do this LRLL things. Let's make that legible. All right. And now the next question we asked was, how are the arrangements connected? Again, I'm giving you one way of answering these questions. It's not the only way of answering these questions. There's lots of ways to answer these and lots of good ways. So here's the different arrangements that we're allowed, given the way we've answered the questions. These are the okay arrangements. We want to know, how are those arrangements connected? Here's one way you might go about answering that. So this is a fairly complicated chart, and I'll explain what's going on here. So if you look at the starting point here, this is where everything, including you and the boat, are on the left-hand side. And then the next thing down, this is the arrangement, the allowable arrangement you can get to from there. So the only option here, and let's keep track of who's who. So let's see. If we go back to the previous one, it goes sheep, corn, coyote, boat. I'm going to add that in here. Sheep, corn, coyote, boat. There we go. The only option, we saw this when we talked about the problem a minute ago, the only real option as your first move is to take the sheep across. Because if you try to take the corn across, the coyote's going to eat the sheep. If you try to take the coyote across, the sheep's going to eat the corn. So your only option is to go here. And now we're going to keep track of everything you can do. So we have these 10 allowable moves. And what we're going to do is use those 10 allowable moves to describe, we're going to hook up those 10 allowable moves by which ones you can get to from which other ones. So once you're in this position where the boat's on the right, the sheep's on the right, but the corn and the coyote are on the left. The only thing you can do is move either here, where you actually go across the river with nothing, or if you wanted to, it's not clear why you would do it, but if you wanted to, there is another thing you could do. You could go back to where you started, right? So you could go across the river once with the sheep, or with the sheep, and then you could come back with the sheep again if you want. But there's no reason to do that. But we are keeping track of all the ways you could do. You can go down here. From there, you have two options: back to where you started, or down to there. See if you can make sense of the next one. Why do I have this weird branching there? What's different about that? This thing. What's going on here? Why do I have a branching in that one?
Probably you can choose to take back the sheep or the coyote. I'm not so sure.
Yeah. So we have options here about which critter I take across next. And so this is something I think is interesting. I didn't know this until I actually did this sort of trick, is that there's two different ways to solve this problem. I thought there was one. Turns out there's two. And they are like interestingly different. I mean, not that interesting, but a little bit interestingly different. So at this spot here, ooh, gray. I didn't mean to choose gray. That's exciting. Let's see what's going on here. On the left side of the river, we have the corn, the coyote, and the boat, and I have left the sheep on the right. And now I have two options for what I can do from there. Either way, I'm taking the boat across. And when I take the boat across, I can either take the corn with me, or I could take the coyote with me. Those are two different things I could do at that point. And I have one other thing I could do, which is go back to where I was, but that's boring, so we're not going to do that. And so from there, we can just keep track of all the possible moves. Each state that you could be in, each way the information can be arranged, each one of these, there's only a small number, usually two, sometimes three, other things that you can possibly do from there. And if you keep track of all of them, then we actually see these two different solutions coming up. So to highlight them, here's one solution. The solution that starts at the top with everything on the left and ends at the bottom with everything on the right. And I've just highlighted what each thing was. First, cross with the sheep, then come back empty, then cross with the corn, then come back with the sheep, then cross with the coyote, then come back empty, and then cross again with the sheep. That is one solution. The other solution is very similar, except right here, instead of crossing with the corn, we're going to cross over there with the coyote. So here's the different solution. It goes that way. You still start at the top with everything on the left. You end at the bottom with everything on the right. But along the way, you do things slightly differently. First cross with the sheep. You then return empty. You then cross with the coyote instead of the corn. You return with the sheep, cross with the corn, return empty, and cross with the sheep at the end. Okay, so the point at this here is like, probably guess and check will get you to these answers faster than what we just did. Yes, but we still actually got more information by doing things this way. By doing things this way, we realize there are two different answers, which we might not have known if we hadn't sat down and diagrammed it out like this. So that's a lot of the time what happens when you start keeping track of stuff very carefully. Not only is that helpful for when the problem changes, it's also helpful because it sort of reveals things that you might not have noticed otherwise, like there are multiple answers. Now, let's see. I think I'm going to subject you to bad artwork again in just a moment, and I apologize. So this isn't bad artwork. This is fine. This was sort of the important arrangement we had, was the coyote is on top that eats the sheep, and the sheep is in the middle that eats the corn. Have that in mind. Here's terrifyingly bad artwork. I apologize. You are welcome to laugh at me. It's really hideous. Let's see if I can move this thing out of the way somehow. Yeah, let's put it over there. Smallify. There. So here's a slightly different situation. You are stuck in a classroom with 3 kids. I'm just going to call them Kid A. Radiohead fans represent. Kid B and Kid C. They're all here. And here's what you know about the situation. Kid A and Kid B are going to fight if you leave them alone. Kid B and Kid C, if you leave them alone. You need to get all the kids on the bus, and you can only take 1 kid at a time. How do you solve this problem? So you got to get from the classroom to the bus, 1 kid at a time. You don't want any fights. You know Kid A and Kid B are going to fight if they're left alone. You know Kid B and Kid C are going to fight if they're left alone. What do you do?
Take them together.
But you can only take 1 kid at a time. Maybe because, so you can only take 1 kid at a time because I didn't draw it in here, but there's Kid D is in your arms. All right, you have like a toddler that you're carrying in your arms there. And you have to keep that one in your arm, in one arm the whole time. And so you're going to grab 1 kid by the hand that's free and take it out to the school bus. And then you're going to go back for it. You have to figure out, how am I going to get all my dang kids on the bus?
Hey, Kid B.
Why? Why did you say that? You're correct. Totally correct. But what made you say Kid B?
Because you have to separate A and B, and you have to separate B and C, so B is in both of them.
Yeah, good. So look, it's exactly like this, right? I mean, it's slightly less drastic than eating. The kids are probably not going to eat each other, I hope. I don't know. I have very exciting classrooms sometimes, but I have not yet had any of my students eat each other. But it's Kid A fights with Kid B fights with Kid C, all right? Just like Coyote eats sheep, sheep eats corn. And we saw the first move we had to do before was that the middle thing, the sheep, had to get moved across. And actually kind of the whole key to solving the problem that we saw before was that the sheep, the middle thing, had to move across, then back, and then across again. And so that tells us how we're probably going to solve this problem too. So take a minute, make sure that I'm not making stuff up, and see if that basic idea still works here. Can we do the same thing we did before?
B.
Yep, B first, and then we think, okay, come back empty-handed, and then we have to take one of them across. And actually, if you just come back here, and instead of thinking about this as sheep, corn, coyote, and boat, you instead think about this as Kid A, Kid B. Oops, I think I have to get it in the right order. What was the order here? The first one is sheep. All right. So I have them in not alphabetical order. What? Stop that. Do what I say. I'm in charge here. This is Kid B, Kid A, Kid C, and then you. This tells you exactly what to do. You're going to cross with Kid B. You're going to return empty. You're going to cross with Kid C. I think that's what that is. It doesn't actually matter if it's Kid A or Kid C. That's the branch point. Pick whichever one you want. Return with Kid B. Go back across with the other kid. Return empty. And then cross with the last kid that you left in the road. So this exact same solution still works, right? The problem is exactly the same as it was before. When I was thinking about how to come up with like quasi real world versions of this. The other example I had in mind was like when I had a lot of family in town for a sibling's graduation and had to figure out how to truck everybody around, right? And I'm like, I can't leave my cousin with my uncle or they're going to get into a fight. And I can't leave my mother-in-law together with this person because they're going to be in a fight. And how am I going to actually solve this? And I didn't realize until I was preparing this presentation that I should have applied the mathematical skills I had learned transporting coyotes and sheep and corn to solve the problem involving my family dynamics. So you may yet find this useful in your life. All right, so it's the exact same problem. You just have to move that middle kid to the bus, then back again, and then to the bus again. And provided you do that, you're going to be fine. And that's what we just saw. This is exactly the same problem over again. Here's a hard question. I want you to take a second to think about it. Can the problem be solved if there's two corns? So instead of just one corn, you have two. Can you solve the problem? And can you be sure that your answer is correct? I think pen and paper are helpful here, and you can sketch stuff. All right. I don't know if you have the answer, but I want to show you something that is maybe worth noticing at this point. And this is a thing that happens when you start solving problems. So I'm going to go back to where we were a minute ago. Sorry if this is making you motion sick. We had these questions that we asked. What information matters? How can the stuff that matters be arranged? How are the arrangements connected? And then how could we keep track of everything? And we spent quite a bit of time kind of answering the different parts. You know, we first said, okay, we're going to keep track of where the sheep, the coyote, the corn, and the boat are. And then we took the time to actually write out all 16 different ways things can be arranged. And we separated out from there the 10 arrangements that were allowed. And then we saw how those 10 arrangements were connected. But at the end of it all, this chart that we built, or this picture, I don't know what you want to call this thing, a graph. This graph was doing all the work for us. And so you'll also notice once we have this idea that, hey, we're going to keep track of things using just these strings of letters, we can skip straight from there to building this chart. Here's where we can start. Here's where we can get to from there. And you can build this sort of graph without pausing first to do this whole step. It doesn't much matter that we did this. We didn't even need to ever know that this was on the table. It's not important. We didn't even need to know that these 10 options were the only options that mattered. That didn't help us solve the problem. What mattered in the end was this graph. And this graph, all we needed to do was start from our representation of the starting point, figure out where we could get from each point that came out of there, and see if we could eventually make it to our ending point. Since we could, the problem has a solution, and actually two of them that we can just see in the graph. One's there, one's there. Okay, and so that's all we actually needed from all the work we did to get here. So when it comes to this next problem, can we solve the problem if there are two corns? We can skip a few steps, and that's good, because if we wanted to do those intermediate steps where we said how many different ways can things be arranged, we would have 32 different arrangements we'd have to keep track of, 2 to the 5th arrangements. 2 choices for the corn, number 1, 2 choices for corn, number 2, 2 choices for the sheep, 2 choices for the coyote, and 2 choices for the boat. 32 different things. And here's a fact about Shay Logan, at least. I don't know if it's a fact about any of you. If you ask me to write down 32 different things, I will mess up one of them. For sure. There's no hope of me getting 32 different things completely right. And so I would like to avoid that step where I write down all 32 options. And it looks like, looking back on how we did the previous problem, I probably can avoid that step. So here's how I think you could proceed. I've highlighted with the blue there, the one that's the boat. Blue for boat, or for water, I guess. I don't know, boats go in water. In some places of the world, water is blue. Nowhere I've ever lived has blue water. I've done a bad thing a little bit, and I apologize. We have corn number 1, and then since we're kind of just adding corn number 2 to the problem, I tossed it in at the end. A better version of me would have put the corns together, and a yet better version of me would have organized sheep, corn, and coyote in a sensible way so that it was like coyote and then sheep and then corn and then other corn. I didn't organize it sensibly, and we're just gonna have to live with that disaster. C'est la vie. Fine. So what we want to think about is the following. Here's my starting point. Everything's on the left. And I want to think, where can I get from there? And here's one way of representing the places I can get from there. Dang it, it's not that. I can get anywhere that has the boat on the right, and where I change at most one of these things to right, because I can go across the river taking at most one thing with me. So I can change at most one of those L's to an R. So that's sort of abstractly the places I can get to from the all L's. The places I can get to from the all L's are the things that have an R in this place and then have at most one R in these 4 places, and all the others are L's. Okay. And so let's just write all of those options down. Here they are. I'm going to highlight in each of these which one's the boat. So those are all the things I can do. I can take my boat across the river. So notice in all of them, the boat switches from L to R. And while I do it, I either take nothing with me or I take exactly one thing with me. And that exactly one thing can either be the sheep, or it can be the first corn, or it can be the coyote, or it can be the other corn. Now take a minute and figure out which of these are okay, because in some of these bad things are going on. All right, I'll show you how I did this. So let's see. I said, oh, they got strangely reorganized. I have no explanation for why they've been reorganized, but they've been reorganized from one slide to the next. I apologize for that. Fine. So the one where you have where you take the sheep across, that one seems okay. All the others have problems, and some of them have a lot of problems, right? So here, you've left a sheep and a corn alone. And so there's going to be some chomping that goes on there. Yep. And you've actually left the coyote and the sheep also. So there's like nom, nom, nom going on there. And here, you've left the sheep alone with all the corn. So the sheep's going to just like, yeah, chomp. Oh, Irene, you said the R and L confused me. Good. So all that matters is that they're different. Good. But this is a really important thing. I find that what confuses one person might not confuse another, right? And that's okay. All right. Ain't magic about like, these are the things that should confuse you. What a strange thing to say out loud. And so some of the time, what I do, if I find that something's confusing me, is I just build myself a key as I go. And so I'll just be like, and then if that's not enough for me, there's two options at that point. What I do when I'm working on problems and I get stuck, confused by my own notation. So the first thing I sometimes do is I try to take the notation that I have, so this thing, and draw a picture of it. And so here's what the picture looks like, right? I apologize again to everybody. God-awful art. I'm glad you got it, but I'm still going to do this because it's fun. God-awful artwork coming up. River. River. And on this one, on the right side, we have a sheep. Oh, God. Forgive me, everyone. Why did it do that? That was weird. Yeah. Okay, so the sheep. This is what a sheep looks like. That's a sheep. That's on the right-hand side. And the other thing that's on the right-hand side is the boat. Boat, there we go. And on the left-hand side, we have the corn, the coyote, and the corn. So the coyote is just like fangs. I don't know. There, coyote. And then the corn. And the other corn. And I do, in fact, if you were to like hang out with me and watch me do research, I would not recommend it. It's a terrible experience. But I do actually draw stupid pictures. I mean, roughly this stupid all the time, just because there's something that happens in the process of turning notation into pictures. And after you've turned your notation into a picture or some other representation that helps you know what's going on, if you just do that a handful of times, the notation starts to become transparent to you. But you have to actually do it. You can't just like close your eyes and like force yourself to see through things by like, I don't know, squeezing really hard or something. You have to actually do something. And the something that works for me and works for a lot of my friends is you transform it a few times and use that to actually get some place. Okay, awesome. Irene, thank you so much for asking. And I hope that's actually Irene and not just what your name is. But if that's just what your name is, then thank you, whoever's name says Irene. There we go. We got rid of that. Okay. This one that is on the far left of my screen is the only okay one. In all the other ones, there's eaten. Ooh. Whoa. Hang on. What's this? How many word problems can you expose kids to solve a problem in 1 hour? Is it possible to expose them to all the math problems they're supposed to answer in their state summative test? How? Good. I don't know the answer to that, in part because I don't actually know what's on the state summative test. This is the first time I'm hearing those words. I will now go look it up before I actually do the Navajo Math Circles again, so I know what kind of word problems are going to be there. That said, what I tend to do in my sessions is start with one of these problems, like the initial one, the sheep, corn, coyote, boat problem. Almost always there's something that the students will do that suggests which direction to go. So here, I've gone in the direction of having an extra corn. I don't always choose to go that route, but sometimes the students will ask a question very close to that, right? You'll be in the process of working through the first example, and they'll ask a question like, yeah, but what if there were extra coyotes? You're like, cool, we're going to toss an extra coyote on and see what happens. Some of the time they'll ask a question like, why don't we have a bigger boat? That's another way you can go. And so partially I can answer your question by saying, I can get through a great many more problems if I follow their interests than if I try to impose mine. That's vastly easier to do in person than it is over Zoom, obviously. I'm forcing you all to follow my example right now, and I don't love that, but that is the best I can do for an answer. I will look at the state summative test, especially if there is like examples I can look at somewhere, because that would be helpful for me to cook up problems that are helpful for you all. Okay, so the only one of these that works is the one, so I'm just going to keep it. And now we want to think, where can I go from there? Okay, and so again, that's the boat in the blue there. That's the boat. Where I can get from something like this is to things that have, well, the boat has to switch sides. And then I can either take something with me or not. But the only option is this guy. So like I'm on the right. The only possibility is to move things from right to left. So the only option is this has to either be L or R. So I really have two options. There they are. One of the options is boring because it's just going back to where I started. And the other option isn't boring and it's totally fine. Nothing's eating anything. So I'll put that one down. And I can carry on in this way. Right? Oop, I forgot to highlight my boat. Here's my boat. Right, so from here, again, the only option I have to move the boat switches from left to right. And then some of the stuff that's with me on the same side as the boat can move, but I can move at most one. So there's four options. I either move nothing, or I move this one, or I move that one, or I move that one. So there's the options, four options. Again, one of them is boring. It's just going back to where I started. And the other three are all okay. So I actually get, unlike the previous one, I get a really big branch. So in the previous case, the biggest branching we saw had 2 coming off. Now we have 3. But from here, hopefully the pattern is starting to make itself clear. I'll grab one of them. It doesn't matter which. I think I'm going to start from the left. And I see, what are the options from there? Okay, so again, I have to switch my boat from right to left. That's the boat swap one. And then I could take at most 1 critter with me. So I'm either going to take 0 critters, or I'm going to take whichever critter this is, or I'm going to take whichever critter that is. That gives me 3 options. Some of them are bad. Some of them are boring. One of them's boring. That one's bad, and that one's bad. Actually, there's only the boring option and the bad options. And so this one's kind of this route is kind of a dead end. The only thing you can do from there is go back to where you were. And then I check the other ones, which you can do bit by bit in the same way. Again, boat has to switch from one side to the other. The things that are on the same side as the boat, you can take at most 1 of them with you. So you either take 0 of them with you, or you take 1 or the other of them with you. Check the options. Gives you 3 options. One of the options is boring. That's always the case. One of the options has eating going on. And one of the options is interesting. Right. Check the last guy. Same story. Boat switches right to left. And at most 1 of the things that was on the same side as the boat switches sides. We see what the options are. Okay, there's all 3 of them. One of them is boring. One of them has some eating going on. And one of them's okay. From here, we're almost done. Because it turns out from both of these, the only thing left is the boring option. We can see that by just checking. All right, so from there, the boat has to switch. The boat has to switch. And while the boat's switching, it can take at most one of the critters with it. So these things that are on the same side as the boat, you can take at most one of them. And over here, the things that are on the same side as the boat, you can take at most one of them. I'm going to do it all at once this time because, we've seen it enough times. So here are the 4 options from here. And here are the 4 options from here. Again, in each case, one of the options is boring. It's to go back to where you were. And let's move this out of the way, up there. In each of the other options that isn't boring, there's some amount of eating going on. And same over here. This is the boring option. And then in each of the other options, there's some amount of eating going on. And so when you're all the way done, here's what it looks like. There's nowhere else to go from here. You've investigated every single option there is. You have to start from this state. And then these are all the options for what to do after that. And notice one thing that did not show up on here is this guy, which is what you were looking for. So if there are 2 corns, you cannot solve the problem. And here's how you can figure out that you cannot solve the problem. By going through and building one of these graphs that diagrams out all the options so that you can see where to go. And now you're done. You've shown for sure that you can't get from everything on the left to everything on the right when you have 2 corners. Can't be done. Whoa. Okay, now there's all these other things that the students sometimes ask about. And so when I've run this problem, these are different things that come up. So some of them ask, what if the boat holds 2? Well, as soon as the boat holds 2, the initial problem's easy to solve, but now the 2 corn problem is actually interesting. And you can solve the 2 corn problem. And the 2 corn problem, the solution to the 2 corn problem isn't very hard. And then you wonder, can I solve the 3 corn problem if I have a boat that holds 2? And you can start to ask these kind of questions. People ask, what if I had, 2 corns, 3 coyotes, and 5 sheep, and my boat holds 17, right? These are kind of things you can actually ask. And once you've started down this road, it's not very weird to go to the next one. Another thing that students sometimes ask about is like, what if we had a monster that ate the coyote? Or what if we had something that corn eats? Like, I don't know, dirt, I guess. I don't actually know it. It's kind of weird, but what if you had something else? What if instead of just having 3 critters, one that eats this one and the other that eats the last one, what if you had a 4th one? Or what if you had something that ate multiples, right? What if instead of having the who eats who relationship be a straight line, what if it was more complicated? The same techniques that we just used, building this big graph, can be used to answer all of those questions. And it's not, I don't want you to think that what I want you to learn from this is that like this building graphs thing is magic. It's really not. It's a tool that is particularly useful for solving a range of different problems. But what mattered about it wasn't that it wasn't the particular tool. What matters about it is once you've settled on a tool, you can go back, revisit the problem you started with, and ask yourself, which parts of this tool building procedure did I actually need? And then you can figure out how to use the tool really effectively for future problems. And that's what we did, right? In the 2 corn problem, we skipped a big middle step that would have taken forever, where you would have had 32 different rows of this big table to draw. We didn't need that because we went back and thought about how we used the tool in the first place. That's what I've got. Thanks for hanging out. I'm happy to answer questions if anyone has any questions. I think there are officially 9 minutes left in the session. I meant to leave 5 minutes for Q&A, but I ended up with more. But thanks, everybody. This was fun for me. I hope it was fun for you, and I'm happy to answer anything you have.
Hey, Shay, I have just a quick question.
Hey, what's up?
I just something that was kind of coming to mind as I thought, well, how could I use a graphing tool like Excel? Like, I was wondering how I could maybe even use Excel to have them do something like this.
Yeah. So definitely for building the chart, like building that big table, right? Excel's the natural tool for that. The big table, yeah. There is almost certainly a way to make, and actually that's a good question. So one thing you could definitely do, you could have them build the table with Excel, and then it wouldn't be hard. It would be, I mean, it probably wouldn't be hard for you and me to convince Excel to do. So actually, I'm going to share my screen again because thinking without writing is not something I'm good at. What? Why isn't it working? There. Okay, cool. So here's a thought I had. I don't know why that's there. That's weird. Cool. So we had this big table, right? If I were smart, it would have gone coyote, sheep, corn, boat. Okay. And you could definitely get Excel to build this big table. And then you could probably add a column that just says okay. And you could get Excel to put like, you could write a formula in Excel that would put down like a yes or a no in here if the row was an okay arrangement, right? So you just tell it, because you can make Excel do things conditionally, right? You can say, if this happens, then write down this thing. And if the other thing happens, write down. And so you could get it to say, just check if, you know, the coyote and the sheep are on the same side without the boat, then it puts down a no. Or if the sheep and the corn are down on the same side without the boat, then it puts down a no. Right? So you could definitely do that. And like, my suspicion is if you're like me and you sat down to try to do that, I would probably do it in stages, right? I would have a column that said like, coyote eat sheep. And that's an easy thing to get Excel to do, right? It would just check if the coyote and sheep are on the same side and that side is different than where the boat is, then it puts a yes, and otherwise it puts a no. And you could do that for each of them. Does the coyote eat the sheep? Is the sheep eating the corn? And so then once you know those answers, you can put them together to get whether it's an okay row, right? So you could get Excel slowly to put these things together. And that would tell you which of the rows are okay. And then what I would do from there is you could probably get Excel to not draw that graph, but do something similar. So we had, actually, let's just go back to the thing. It's not the big one, let's do the little one. My goodness, it's a long ways back. Now, here we go. A different way of representing this is the following. You could have, I'm going to start showing you the different way of representing it, and I'm not going to finish the job. If you ask my wife, she'll say this is my usual way of doing things. But you could take all 10 of these things, and you could make a big 10 by 10 chart that has just these things labeling each row and each column. So just take all 10 of these, put them as a label for the rows, same 10 things, have them as labels for the columns. Okay, and now I just ask, can I get from this one to this one? If so, I'll put a check in here, and if not, I'll put an X in there. You can get Excel to check that, right? And so you would have a separate, so you would first use Excel to figure out of the 16 options, well, you could use Excel to build the 16 options. Then you get Excel to tell which of the 16 options are okay. And then if I want to know which ones can I get to from which, instead of building a chart like this, what you would probably want to do is build this big 10 by 10 thing like that. And then from that, then by hand, you could probably build this big graph that we have over here. So along the way, they would learn a lot about how to get Excel to do different things. And there are going to be many different clever solutions for doing these sorts of things. But yeah, that's actually a fun question. I never thought to use Excel to do it, but it definitely could. And it might even make it might make me trust my answers more.
Thank you.
Oh, yeah, thank you for the question. That was great.